Hi guys, here's another vertical projectile question of two balls. It says ball A is projected vertically upwards from the ground. Here's ball A. If you look at the diagram, this is the ground. It's projected upwards with a speed of 30 meters per second. We're given the initial velocity there. It says ignore the effect of the air friction. Now I'm not gonna do 3.2. Let's go to 3. I'm not gonna do 3.1. Let's go to 3.2. 3.2. It says calculate the total time that the ball is in the air. This is simply mean, guys, the ball that it's in the air, the ball, wherever that is going to do, it's going to go up and reach the maximum height, and it goes back to the ground. So since we're focusing on ball A, we're going to choose up as what? As positive. So if we choose up as positive, this initial velocity is going to be what? Positive, right? And then since it's thrown from the ground, the ball A, when it reaches the ground again, it will reach the ground with the same velocity. We'll say it's the final velocity, but it's going to be negative because it's going downwards, right? So even the displacement here, what do you need to understand? As it goes up, the displacement that it's taking, it's going to be what? Positive y. And when it goes down, it's going to be the same displacement but in the negative direction, and therefore the change in displacement there, it's going to be what? 0 for ball A. The time it's in the air as it return to its original position. So guys, when we wanted the time that it took there, so what do we have there? We have the initial velocity of positive 30 meters per second and the final velocity, which is negative 30 meters per second, and the displacement for the time that it's in the air, it's going to be 0, and we want what? The time for the total time it's in the motion. Guys, there are many ways that you can do that. I'll show you. So what are you going to do there? Which formula are we going to use from the equations of motion? The formula that we're going to use there, it's this one that says Vf is equal to V initial plus acceleration times time. So our final velocity, it's 30 meters per second, and initial it's 30 plus the acceleration there, it's going to be what? It's going to be negative 9.8 times time, and then it's going to be negative 30 minus 30 when we transpose that, 9.8 change in time, and then we divide by negative 9.8 both sides. When we divide by negative 9.8 there, both sides will have time is equal to 6.12 seconds. That's the whole time for the journey to return from the starting point to return to the starting point again. So guys, this is an alternative way where you can do this. You can calculate the time from the starting point to the maximum point, and then it's the same time from the starting point to the maximum point is the same time that it will take from the maximum point to the starting point again, right? So what are we going to do there? We will use the same formula. But now we are taking this segment. So what do we have there? We have the initial velocity that is positive 30 meters per second, and the final velocity to the maximum point is what? Is 0, and we are looking for time, and the displacement for that we do not know, right? That's not going to be 0. So when we use this formula, we'll say Vf is equal to V initial plus acceleration change in time. The final velocity, if we're taking this segment now, so it's going to be the final velocity is 0, and the initial is what? Is 30, right? So plus acceleration, it's negative 9.8. we are looking for time. So when we we're going to have 30 in this side and a negative 9.8 change in t. When we divide by negative 9.8 there, when we divide by negative 9.8 there, our change in t, it's going to be 3 seconds, 3.06 seconds, right? But that's not the entire time. Remember, we want this time, the entire time. We wanted the whole time of the journey, so we this is the half time, so therefore we'll say total time, it's going to be 3.06 times 2, which is it's going to be 6.12 seconds, which is similar to same answer that we got from the first time, from the first option. Now guys, let's go to a 3.2.2. 3.2.2, it says the distance traveled by the ball A during the last second of its fall. Guys, before, I'd like to give you a sketch. 3.2.2. The ball A, it starts from the ground to back to the ground. But now what they want here, they want the distance. Remember, when they say the distance, they want the distance traveled, the distance, it must be positive during the last 1 second, last second. Okay guys, now if you look at this, the last second, let's say the last second, it will be there. It will be there. This is the last second. You see, the whole journey, it traveled for 6.15. So the last second there, we simply mean the last second there, which is 1 second there. So here, the time that it traveled, it's going to be 5.112, because out of that 6.112, we minus 1 second, it's going to be 5.12 seconds. So the time it took till the last second there, it took 5.112, right? Now if we want that displacement, there are things that we need to know there, right? So these are the things that we need to know. We need to know its final velocity before, at the beginning of the last second there. We wanted the final velocity here, right? And the initial velocity here, we know it's what? It's 30 meters per second, right? And it's positive, and this velocity, it must be negative there. I hope you get that, guys. So the entire journey, it took what? Let me repeat it again. The entire journey took what? 6.12 seconds, but we want the distance it traveled of at the it says during the last second of its fall. So the last second of its fall, that means it's 6.12 minus 1, it's that. So the last second it traveled for that time. So we wanted this velocity at this point. So this is what we're going to do using what we have to get the distance it traveled for the last seconds. These are the things that you need to consider here. You need to first calculate the final velocity, right? So if you can calculate the final velocity there, it will help us to get what we're looking for. Let's see if we can calculate the final velocity there. So if we can say v final is equal to v initial plus a t, right? Okay, let me show you what we have first. So we have the initial velocity is 30 meters per second, and we're looking for the final velocity, which is going to be negative because downward is positive, and we want the distance, right? We want the distance, and we do have the time. The time, it's 5.12 seconds because it's the time that it took in the last second there. So we substitute what we have. The final velocity is the one that we're looking for, and the initial velocity is 30, and the acceleration it's negative 9.8, and the time it's 5,112. So punching that in the calculator, we'll say 30 plus negative 9.8 times by 512. It's going to be, so the final velocity at this point, at the last second there, the final velocity is 20. It's negative 20,176 meters per second, right? So now we want the distance that it traveled. So this question, guys, it's looking for the distance basically in the last, it's looking for it's looking for this distance here, the distance it traveled in the last second. So now this velocity that we calculated, the final velocity here, we're going to take it as our initial velocity. Now it will become, from this journey, guys, from this segment, let me write the segment again, from this segment of this is what I'm drawing here, this part. So guys, from that guys, the time, we know the time, it's what, it's 1 second, and the initial velocity at this point now, it's what, it's negative 20,176 meters per second, and we're looking for this displacement that it covered from here to here in the last second. So what are we going to do now? We're going to use the formula that says change in y is equal to initial velocity times change in time plus half acceleration change in t squared. Why do we use this formula? Because we are looking for a displacement. We do have the initial velocity, we have the time. The time, it's 1 second. Now it's 1 second in the last second there, it's 1 second. So at the velocity, the initial velocity, it's the velocity that reaches at this point there, it's this. Guys, I hope you understand that. Now the initial velocity, it's negative 20,176. The time, it's 1 second plus half acceleration, it's 9.8, and the time, it's 1 second. If we punch that in the calculator quickly, it's negative 20,176 times 1 plus half, negative 9.8, 9.8 times 1 square. Don't have to put that in the calculator. So the answer here, we get the negative answer, it's 25,076 meters. Remember, guys, we want this is the distance it traveled in the last 1 second, the distance it traveled in the last second. So it needs to be positive. When we talk about the distance, it needs to be positive always. So the distance is going to be 25, and we round off into two decimal places, 25,0.8 meters, right? I hope you get that, guys. If you don't get that, guys, please rewatch the video, and you will get it. Let's look at 3.4, the last question. It says sketch velocity time graph for the motion of both ball A and B on the same set of axes. Clearly label the graph for balls A and B. Indicate the following. These are the things that you need to indicate in the graph. It's very important you get the marks according to them. Now, time taken for both balls A and B to reach the ground, we need to show the time they take to reach the ground. Now it says time taken for ball A to reach its maximum height. That's what you need to show. Guys, we've already drawn the velocity time graph. Whatever is it. Now, what do you need to note? That ball A was traveling from the ground and given the initial velocity of 30 meters per second, and it went up, and the velocity decreases and reached its maximum height, and then it went back to the ground and the velocity increased. So the velocity was going in the positive direction initially until it reaches the maximum point, which is the velocity is what? A 0. It's 0 there, and it's 30 the initial. Let's show it in the graph that this section. So it's going to be, say it's 30 there and it's 30 there. This is the positive side in the graph, and this is the negative side in the graph. You don't have to show the positive and negative in the graph. Now remember, we chose up as positive, so your graph is going to initially start up. So as the velocity, the 30 that it was given, the projectile, it decreases up until it's 0 there. So here the velocity decreases. We show here it's going to be like this. It decreases and reaches the maximum point. This part here is the maximum height, which is this, and then it continues and reach here by the same velocity, which is 30 meters per second, but the negative one. So we need to prolong the graph until that point. So this part of the graph, it's this part there, right? So this is the velocity here, and this is the velocity. So remember, they said we should show time for ball A until it reaches the ground. So the time there for A, it's 6,12, right? And then when it reached the maximum height, it's the half of this time, right? So the time here, it's going to be 3,06, right? Now let's look at this is ball A, now let's look at ball B. The curve for ball B, the initial velocity we calculated in 3.3, it's this, it's 5,05, the 8,05, sorry, that's the initial for ball B. So let's say the 8,05, it's going to be there, and they reach the ground. So it's going to be, but remember, ball B starts 1 second later. So when it starts 1 second later, so it's going to start there. And remember, the gradient, it needs to be the same, which is the slope of this curve, they need to be the same. So it's going to be not 1 second later, it's 2 seconds later. 2 seconds later, so let's say 2, it's there. So ball B started 2 seconds later, so the curve, it's going to be like this, right? It's going to be like that. So that's ball B, right? Ball B, remember, it comes from the height and like this. So its curve, it's going to be longer. This part, come on, this part, it's longer than this, which is this part is this, and this part is this part, right? Okay guys, let's double check if we have drawn according what we're supposed to, the time taken for the ball A and B to reach the ground. So the time to reach the ground there, yeah, from 2 seconds to that time there, it's for ball B it's 4,112, but for ball A it's 6,112. And what else we're supposed to show? The time taken for ball A to reach its maximum height. I've shown that. This is the time it took to reach its maximum height. I've shown that. Okay, that's it, guys.